I don't have any. Oh, fuck it. I don't have any diagrams. I just thought of it. And I don't know if I read it somewhere or saw it somewhere or something like that, but I wanted to put it out there and then people could build on it and see, everything else. But I was thinking, like, there's got to be a way of using electromagnetic force or whatever to power something. And I found out there is a way. And it's not purely nuclear, it's not purely electromagnetic, not purely, you know, um, it's a combination of everything. It's like using all these forces at once. And like, how do you move something with no friction? But that's the key. You use no friction to your advantage. You use the absence of material to your advantage because we keep focusing on chemical, chemical, chemical. What happens if we just say we're not going to use chemical energy? And then how would you do it? You'd be a combination of things. I don't know what you would call it, but it's fairly simple. I don't know if someone already came up with it, but that being said, I understand the feasibility of using it, and I think I'm fairly certain it is practical now. It would have to have trials or whatever. And let me just break it down real simply. You would have a magnet. You have another magnet, right? And it would push off the other magnet, so it would push it forward. So you have this magnet, and it push it this way. So, and these things are connected, right? And they don't have to be connected, but it pushes it off. So this magnet will increase intensity, shoving that forward, and then it would relax just enough to bring it in. So there we go, boom. Now, if these are two different masses or whatever, right? There's going to be movement, right? So this has more electrical magnetic energy, more magnetic force or whatever, or repelling energy of this magnet. So it's going to shove it. So it pushes it forward, boom, and then it brings it forward. And that difference is, if it has the same mass, it would just go back and forth. Now, if it's different in masses, whatever, it's going to start to move. That's the kinetic energy. That's electromagnetic energy. Well, how are you going to power these magnets? With um, the nuclear power source. And that's how you do that. And that's how you do it. So, okay, well, does it make it, it's just like, so it's sort of like hydraulics. You know what I'm talking about? How can you make that much electricity to power something? Well, you use the mass of the ship. And how can you move the mass of the ship? So readily, there's no friction. And then you think about it, well, how much is that? Hey, how you doing? Get wrecked. And then if you look at it like this, right? Well, if you push the ship forward, right? There's only probably going to be like that much space to push it forward. That difference in masses or whatever. But you're not looking at it like that. Don't look at it the distance of how much the magnet force of how much you're pushing it with magnets. Because the way you're pulsating, right? It'd be like, and honestly, it'd probably be cyclical per second. And if you could get up to like 1,000,000 times per second, it's that distance per million. And how long is that? I mean, it could be as long as New York to California in a second, times the mass of both objects are being moved. And that's how much kinetic energy you're unleashing in a second to power a ship in space. So it's sort of like, if you see a cat move, like the two, it moves here and then moves there, moves here, moves there, the four legs. It just keeps springing forward or whatever. And it could be that quick, that fast. And that's how you could adjust satellites in space by having, solar power energy, whatever, having that little drive, it just adjusting the orbit. There's that pulsating effect. Keep pushing it up, because it just constantly pulls it up, I'm just saying, you know, so I just thought of it. Difference in masses, alternating frequencies of that magnet powered by nuclear energy using the